Good afternoon everyone, and welcome to my presentation on the provision of digital quantification learning on quantity surveying programmes, the drivers and the barriers. And last year I was looking at this with a dissertation student, and one of the questions the student said to me, why are we still doing takeoffs manually? Everybody in the industry is using some form of software to do the takeoffs. And I said, yeah, fair point, but you need to understand how to do takeoffs. But he said, why? So we did a bit of research into establishing why this is the case. So development of measurement skills in QS students obviously is happening in a rapidly changing environment. Obviously advances in technology are now seeing basically the demise of manual takeoffs in industry, and again it's important that us in academia need to reflect that in terms of our course provision, in terms of our development of students. So as I said before, producing measurements, producing bills of quantities has now become largely automated within industry, but generally within academia the conventional approach is still to introduce measurement being done manually, taking out drawings, 2D drawings, either actual drawings or drawings on a computer screen, and getting the students to actually use dimension paper and set out the takeoff in a traditional fashion. But again, the students are going out into the industry, they're not doing that anymore. They're using bespoke software. In a lot of instances, are they using some form of generic software to develop their takeoffs. So again, obviously quantification has taken great strides forward from initially being dealing with two-dimensional drawings and inputting dimensions into a computer program to produce quantities, to now having a situation where you've got a 3D building information model where you can abstract quantities. So it is changing rapidly, and again, us in academia need to reflect that. The big issue we find in terms of doing that is, how do we then integrate the rules of measurement? How do we get learning and develop learning in terms of, obviously in Northern Ireland and GB we use the new rules of measurement NRM2. Obviously in the Republic of Ireland you're now, I think, heading towards using the 5th edition of the agreed rules of measurement. So that's a challenge as well in terms of, yes, how we integrate computer aided takeoff, but how do we then embed learning in terms of using the rules to develop the takeoff. And again, this goes back to the whole issue of trying to embed learning in terms of measurement. A lot of students struggle with this. Understanding drawings, understanding the technology, then understanding the format, setting out dimensions, and obviously then having to deal with computer-aided takeoff. So, as the industry has moved to predominantly using software, there is a need to develop more ability in students graduating, going out on placement in the use of computer-aided takeoff software. What are the drivers? Again, we found in terms of our research, a lot of the drivers for adopting digital quantification mirror those within industry. Obviously increased productivity, better response time, hopefully improved accuracy in terms of what they're producing, improved quality control, again more transparent working methods, improved communication, and hopefully the promotion of greater and more efficient collaboration, because again within academia we try and introduce students to working with other students in other programs, for example architecture, technology, building surveying, construction management, etc. So again, yes, digital quantification could facilitate greater and more efficient collaboration. Other drivers, particularly when you think about technology and understanding how buildings are put together, is if you're using BIM, the enhanced visualization of data and project information using a three-dimensional model. And again, provision of greater flexibility and adaptability in terms of how to manage change in projects, in terms of case studies, etc., where you're introducing changes into the quantification of something or other. For example, maybe a reinforced concrete frame, looking at it in comparison to maybe a structural steel frame. Again, obviously, using a computer-aided takeoff software can maybe facilitate that, and using a three-dimensional BIM model can make that more understandable for students. However, the main driver in academia is to prepare students for industry, because, as I said before, manual taking off is virtually redundant out in industry. Everything is now focused on using some form of bespoke or generic software to provide quantities. So again, if we don't do it in academia, that puts the onus on employers when they take on a graduate, when they take on a placement student, to start from a very, very basic level to provide training in terms of how to use software. And again, it's worth noting that quantity surveying graduates in the future will be the influencers of the construction industry and its implementation of digital technology, and therefore we need to be playing our part in terms of embedding digital skills in this core skill of the quantity surveyor. The barriers, again, the barriers we found mirrored a lot of what happens out in industry as well, in terms of how companies view the integration of digital quantification. Again, lack of digital literacy is an issue. We found that with students as well as academics as well, because obviously the whole digital technology is moving at a rapid pace. But again, lack of support from industry and cooperation with consultancies and companies being tentative in terms of working with us is another issue. In terms of embedding digital quantification, in terms of sharing information, using case studies, etc., for preparing quantities, can be a barrier to implementing digital quantification. Probably to a lesser extent, accessibility and affordability of digital technologies was highlighted as a potential issue. But again, obviously, a lot of companies now, CostX, BuildSoft, etc., are now providing free or fairly cheap licenses for use in the academic environment. So again, probably this isn't as big an issue as what it would have been maybe a number of years ago. Obviously, software companies are now seeing the advantages of using this as a marketing tool for their software. Lack of investment in computer hardware, poor managerial leadership and attitudes towards incorporating digital technology can be an issue as well within academic institutions. Other barriers identified: software not being user-friendly, software compatibility issues, and probably another one that's coming up now, intellectual property, privacy, copyright information. That maybe goes back to collaborating with industry, where industries may be reluctant to provide information to be used in an academic forum. So therefore, these barriers, like industry, can be categorized as technological, financial, organizational, and psychological. Psychological is the mindset to adopt digital technologies. Organizational is obviously senior management in terms of buying into the whole process of facilitating greater use of digital quantification within programs. Financial, probably not so much an issue. Technological, again, software compatibility and software user friendliness is probably now less of an issue than what it would have been probably a number of years ago. So a survey was conducted amongst the academic community in GB in Ireland, and we targeted probably over 60 third level institutions. We targeted 91, 92 individuals. We sourced contact details on the RICS and the SCSI websites and third level institution websites, and sent inquiries to these individuals would they take part in the survey. Disappointingly, only 31 respondents took part in the survey. Again, one individual said they were suffering from survey fatigue at that time of the year, so it would have been good to get a more detailed response from a range of third level institutions. But just a quick demography there of the responses. You can see we've got 5 responses from the Republic of Ireland, 3 from Northern Ireland, 10 from England, 7 from Scotland, and 6 from Wales. So we've got fairly reasonable spread of responses from UK and Ireland. From the responses, 18 institutions deliver learning and assessment in digital quantification in first year at undergraduate level. Moving to second year, responses indicated that 29 out of the 31 institutions provide learning and assessment at that stage of their programs. With regard to third year, 11 institutions have digital quantification at that stage in their program. These were institutions primarily in the Republic of Ireland and Scotland who have a 4-year full-time program, as opposed to England, Scotland, or England and Wales and Northern Ireland that predominantly offer a sandwich program where the third year is spent in industry. In final year, at undergraduate level, 19 institutions out of the 31 provide some form of digital quantification learning. And then at postgraduate level, of the 7 institutions that were identified as providing a QS course at postgraduate level, they all have incorporated some level of digital quantification and learning. So again, this table here gives an indication there of the number of programs that have quantification. There's one institution only has quantification delivered in first year, which is quite surprising. 6 institutions deliver quantification in first and second year. 1 institution in first and final year. Looking at the 4-year sandwich program, there's 8 institutions have digital quantification in year 2 and final year. And then of those 4-year sandwich programs, there's 4 institutions delivered across all their academic years. That's first, second year and final year. Moving on to the 4-year full-time program, there's 3 institutions have digital quantification in second and third year. 2 institutions have it in first, second and third. 2 institutions in second, third and final year, and then 4 institutions that deliver some form of digital quantification learning and assessment across all academic years. So again...
So you say that some institutes did no measurement in some years?
Yeah. Or no digital quantification.
Okay.
No digital quantification in some years. That's what's coming through here. So there's a disparity in terms of the approach to delivering digital quantification. It's surprising there that one that is only delivering it in the first year, which is a very strange approach. In terms of the software that's used, predominantly the one that jumps out here has been used predominantly is Microsoft Excel. 27 institutions use Excel in some shape, form or manner to carry out digital quantification. That's followed by CostX and then followed by Buildsoft Qubit and Bluebeam. But as you can see there, CostX and particularly Microsoft Excel are far ahead of their rivals there in terms of the software that's used to deliver digital quantification. Now, taking that a stage further, it's interesting to note here, as you can see on the table, most institutions use 2 or more software platforms to deliver digital quantification. There's some institutions use 3 or 4 platforms to deliver digital quantification. But as you can see there again, Microsoft Excel is used in combination with CostX or BuildSoft or the Autodesk software package. So again, that's interesting to see as well, that in the institutions they're not predominantly using one form of quantification software. So in terms of the design information that's used in the delivery of digital quantification, 11 respondents said their institutions used drawn information solely in a PDF format. 10 respondents used a combination of PDF and DWG. 5 respondents indicated that their institutions use BIM models in addition to PDFs and DWD formats. 2 respondents said BIM and PDF format. 2 respondents indicated their institution used solely BIM models, and 1 institution or respondent indicating that they only use design information in DWG format, which is unusual. But as you can see, in most instances there's a combination of formats used. Disappointing probably that we're still low in terms of using the 3D models in terms of quantification. We're still relying heavily on the PDF and the DWG in a lot of instances. Then we asked the respondents to identify what they seen as the drivers, and obviously again just in the hierarchy here of the main drivers, obviously better preparation of students for their career in a rapidly changing and rapidly adapting digital industry, improving efficiency and transparency of the quantification process, embedding the importance of better collaboration and communication in a digital environment, and again improving the speed and accuracy of data processing and analysis, and attributes that one respondent highlighted that this is what employers are now looking for increasingly in QS graduates, is that they're able to deal with data and process and analyse it in an efficient manner. Probably again, enhanced visualisation, moving towards the technology and developing students' understanding of construction technology, enhanced visualisation, and finally improved accessibility to digital quantification software and support has also been a game changer in terms of embedding digital quantification in academic programmes. Main barriers, again, replicates in a lot of instances what's happening in the industry. Lack of understanding of digital technologies, particularly when we look at this from an academic perspective. From first-year students, many first-year students don't have even basic skills in the use of Microsoft Excel, for example. Lack of appropriate resources to support digital quantification learning. That's obviously going back to maybe greater collaboration with industry in terms of sharing design information. Limited digital literacy among academic staff delivering modules was highlighted as a barrier. Limited training and support again was highlighted, but for most respondents it wasn't a major issue because most software providers now are very good in terms of the support that they provide. Again, difficulty in obtaining design information is linked back to lack of appropriate resources. So again, there's a need there for possibly greater collaboration with industry, and probably probably a personal one from myself here, students being able to share information in a digital environment easily and its impact on ensuring academic integrity. is a major issue going forward, and I had a chat with the representatives of CostX there earlier this morning about that. Lack of institutional support was highlighted, cost of implementing and maintaining and updating digital quantification software, and again, qualitative feedback I got, a view among some pedagogists that there's an over-reliance on technology which may contribute to restricting the development of critical thinking and problem-solving skills, was identified as a potential barrier in terms of teaching and learning people within institutions. So I then asked the question, well, could the RICS in the UK and the SCSI in the Republic of Ireland do more to help in terms of the embedding of digital quantification and quantity surveying programs by possibly developing a specific digital quantification competency? And again, I was slightly surprised at the response to this here. Only over half the respondents said yes. 29% of the respondents were unsure, and 19% of the respondents said no. And to me, I think there's probably a need now, if we're going to move forward with digital quantification, there's a need to embrace this by having this within the assessment of professional competence as a defined competency. The survey also questioned the suitability of the current methods of measurement that are in use. Obviously, NRM2, ARM4, if you want to move into the civil engineering field, the current CESM document. And again, 28 of the 31 respondents indicated that the respective methods of measurement were suitable, with the remaining 3 saying they weren't. But again, some qualitative feedback felt that the methods of measurements weren't that user-friendly in terms of building up descriptions, and they were still very time-consuming, and it still was an issue even within the digital forum. Building up descriptions was still time-consuming and cumbersome. So, conclusion. There obviously is, as I highlighted earlier, a variety of approaches to delivering digital quantification across institutions in Ireland and the UK. As all degree programmes are either accredited by the RICS or the SCSI, there is a need for greater standardisation where you've got a competency there, because in most cases when you're developing a QS programme or putting it through revalidation or programmatic review, there is an emphasis on ensuring that you're embedding all the competencies within the delivery of your programme. So again, if there was a clearly defined competency in terms of digital quantification, it possibly would set the framework for a more standardised approach to embedding digital quantification across quantity surveying programmes. Also again, the issue of digital literacy among new entrants to the programme. Again, students come from a variety of backgrounds, may not come from a particularly strong emphasis in terms of using digital technologies. So perhaps maybe in the first year of programmes there should be more of an emphasis on ensuring students are at an appropriate level in terms of using bespoke or the generic software of Excel, Word, etc., so that when they move on in subsequent years to using the bespoke software, they're more familiar with using software. And again, probably greater collaboration with software providers needs to happen as well. Yes, it's good, but I think that's something that needs to develop. And again, there needs to be greater integration and collaboration with industry in terms of developing resources that can be used for the delivery of digital quantification. And again, technology again is rapidly moving forward. I think at a higher level above course teams, there needs to be a strategic plan for adopting and embedding and advancing the use of digital quantification within programmes to ensure that the programmes remain current and viable in terms of their relevance to industry. It simply can't be an ad hoc approach to it. I know from my own experience within my own institution, there's very little emphasis when you go to a revalidation or a programmatic review in terms of, well, what are you doing in terms of embedding digitalisation within your programme. It's not one of the main categories or at the forefront. They're talking about sustainability, they're talking about, you know, feedback, assessment, etc. But digitalisation, particularly in a vocational programme like quantity surveying, is way down the list in terms of priorities.
So have you got a room full of quantity surveyors then, have you?
I'm not sure what the demographic is. I know what there's one in the back there. So to conclude, I think there's a significant opportunity for QSs going forward to improve efficiency and accuracy of construction cost management, and competence in digital quantification technology can facilitate that. So I think.